Our next speaker is Kawai-san, one of our many regular contributors to the conference. And I hope he's got his slides ready. So he's going to be talking today about pseudo-haptics by stereoscopic images and the effects on muscular activity. So I think this is a slightly different topic, but be interesting to see. I know many people have experienced the feeling of something when they see things. So it'll be interesting to see what the results will tell us.
For your kind introduction. I'm Takashi Kawai. I'm from Waseda University, Japan. Today, I will talk about the stereoscopic 3D imaging, not only seeing, but also touching. I would begin the background of the research. With the development of augmented and mixed reality technologies, the attention has focused on user interfaces for 3D images. This image shows an example, the coexistence with 3D images in augmented or mixed reality environment. This is the concept or background of our study. In particular, mixed reality systems have been proposed in which the interaction by direct touching the 3D images with hand or finger, such as HoloLens, and various methods has also been proposed for the feedback of the sense of touch. But we have focused on the pseudo-haptic for the tactile sensation by visual stimulation. The pseudo-haptic is a tactile illusion, unlike tactile feedback by a force feedback or vibration to the users. Pseudo-haptic is classified as the concept for providing cross-modal information in which a certain sensation is supplemented by other sensory information. This image shows an example of our proposed system in my talk, and we intended to supplement the tactile sensation by visual stimulation in this system, but I will explain the details about this system later. In early 2000s, we started to conduct the pseudo-haptic inspired by the rubber hand illusion. The rubber hand illusion is the illusion that an object separate from the body, like such as the rubber hand, this one, is perceived to be a part of body by visual tactile stimulation. So at the first trial, we carried out experiment to reproduce the rubber hand illusion in virtual space as a pilot cross-modal system using 3D display. The right movie shows our experiment using the 3D display instead of the real rubber hand and the shield to hide the real hand. Then we have tried to induce body images using the cross-modal system or stimulation and applied it to safety education using simulated experience of mock accident. So this system was commercialized in 2006, more than 10 years ago in Japan, and the various versions are still available. This movie shows demonstration of the system. So you can, user experience the mock accident during cleaning the factory machines. Of course, without tactile or force feedback. That's quite important point, this system, of course. And in recent, we have proposed a pseudo-haptic system that induces a subtle, quite weak tactile sensation using 3D images presented by a binocular see-through head-mount display. In the system, the participant wears a binocular see-through HMD, and the 3D image is floating within the reachable distance. The participant places his or her hand as if touching the viewed object to be or resting on the hands. By adjusting the hands to touch the object visually, and then make a slow speed visual motion of the head or object, and the participant experience the subtle or quite weak tactile sensation, such as the slight breeze or a cool or warm sensation. This is the the pseudo-haptic system in this talk. So, okay. Our current issue is how to evaluate the intensity and the characteristics of this kind of subtle tactile sensation induced by the pseudo-haptic system. So the objective of this research was to evaluate the pseudo-haptic system from the viewpoint of touching 3D images. Specifically, we carried out objective evaluation by measuring myoelectric potentials when pushing 3D images of the sphere. So as you can see, this is the 3D images of the sphere with the palm. This video shows the task in the experiment. As you can see, the interaction of the sphere during contact is represented. And in addition to the myoelectric potentials, the subjective evaluation was also performed. This picture shows the experimental layout. The sphere was presented by the see-through head-mount display about 40 centimeter distance. So in this experiment, we used Epson Movelia BT200 for the see-through head-mount display. And the motion sensor was placed on the table, and the position of the hand of participant was measured. The myoelectric potential during task were measured using a bioamplifier. So this is the experimental layout in this study. In the experiment, we set 4 conditions. The condition 1, sorry. Condition 1, this one, was a control condition in which the hand motions were measured without presenting the sphere or any 3D images, so just moving the hands. And the condition 2, this one, was a condition in which the sphere was presented and there was contact interaction. And condition 3, you can see the computer graphics hand model here. So in this condition in which the CZ hand model was superimposed on the hand and synchronized with the hand motion, This model was intended as a cue for judging the contact between the palm and the sphere. And fourth, the condition 4 was the condition in which there was no interaction. So even in the moving the hand, but the sphere is doesn't occur the interaction. For the myoelectric potentials, two measurement positions were selected from their relevance to the task. The task is like this, and the extensor digital, this one, which those flexes, so the bend back the hand joint, and how do I say that? Flexor carpi radialis muscle, which causes inward rotation of forearm. So this picture shows the positions of the electrodes. As subjective indexes, we asked these 4 questions. The question 1 is about the realistic sensation of the 3D images. And the question 2 is about the touch, and the 3 is about strength of illusion. And the question 4 is about the awareness of body and force. These items were not asked for condition 1 because there was no 3D images. The participants were 14 males and females with normal binocular vision, and informed consent was obtained in writing from all the participants in advance. After the practice of experimental task, condition 1 was carried out, and the remaining 3 conditions were carried out in random order. This movie shows the condition 2. The sphere is presented with the contact interaction. Okay, I will report the results. The analysis of myoelectric potential was carried out for 11 of 14 participants without measurement errors. This figure shows the results for the extensor digital. The vertical axis shows the root mean square, RMS, which were used in analysis of the amount of muscular activity. So basically the normalized data. And from multiple comparison of RMS, a significant difference was found for the condition between condition 1 and other conditions. And the marginal significance was found between condition 3 and condition 4. This figure shows the results for the flexor carpi radialis muscle. From multiple comparison, no significant difference was found. This figure shows the result for the time required for one action. So that's the touching the 3D images. So from the from the multiple comparison, it was found that there was a significant extension for condition 2 and condition 3, where interaction was generated during contact. On the other hand, in subjective indexes, condition 2 and condition 3 were significantly higher than condition 4. This figure shows the results for the question about the feeling of touch. And this figure shows the results for the question about strength of illusion. And this figure shows the results for the question about awareness of body and the force. As you can see, the results for these questions show a similar tendency. So from the objective indexes, the amount of muscle activity in extensor digitorum was marginally reduced, and required time for the task, the one action, was significantly extended in conditions with interaction during contact. So in the subjective indexes, scores for the feeling of touch, strength of illusion, and the awareness of body and force were significantly higher in conditions with interaction. So considering the objective and subjective indexes, it was found that the tactile sensation was induced by the 3D images, and the motion of the participants were affected, and this was reflected in the muscle output. And it is considered that the main factor for this was interactive representation of the 3D image during contact. Okay, I would like to conclude my talk. In this research, we carried out evaluation of pseudo-haptic system which induced subtle sensation, subtle tactile sensation, focusing on the muscle output of participants during interaction with 3D images. From the results of experiment, it was found that the muscle output for touching 3D images was reduced, and the action time was extended by the increase of the subjective illusion strength. This tendency was significant, and the condition with interaction of 3D images were represented. Therefore, it is suggested a kind of, how do I say, the cautiousness or a bit careful touching may have been added in the action of the participants as a result of the interaction during contact. And this suggests the pseudo-haptic in this research could affect the action of touching 3D images. So in the next step, we aim to conduct the characteristics between the visual representation of the 3D images and the action by the participants in terms of the pseudo-haptic. Thank you so much for your kind attention.